Maya YouTube and the Binatech Facebook page. Please place your questions there, and we'll try to answer at the Q&A session at 11:30. Even if we manage to answer all of the questions, we try to answer it at the page itself. So the three of us will try to accommodate all the questions. So let me introduce you to the first panel member, Engineer Kok Peng. I can say as he's one of the prekasifu in the industry, with 33 years in the cement and concrete products manufacturing industry, covering concrete pavement, CMUs, aggregates, precast concrete and cement products, design, of course, production, KQC, logistics and site implementation, and he is now the director of IBS Technology Solutions Berhad. The second panel member is T.S. Sharul Fitri from UiTM Penang. He is now the senior lecturer there. Started his career in 1997 with a consulting firm, and he entered the academic line in 2004. And T.S. Sharul, he is an expert in artificial neural network, deep learning, and data analysis and predictions. So I hope that we can get as much info as possible from these two distinguished panels, and I hope we can share as much as possible to the listeners who are coming from the Tvet line, both the students as well as the lecturers. Before I invite Engineer Ng, let me proceed with the introduction of this session. Like I mentioned, I will share on the related policies as well as the construction tech. I start with the policies first. Okay. Mainly, there are three major master plan, which I believe will be good reference for the Tvet industry. The first one will be the National 4IR policy, the National Fourth Industrial Revolution policy, which is just being launched 2 days back. This policy is supposed to bring us, to lead us regarding the IR 4.0 implementation, to coordinate all those activities by various departments, government departments, and to engage the industry to support us on the ethical use of 4IR technologies, which is in line with the coming RMK 12, which is the 12th Malaysia Plan, as well as supporting the Wawasan Kemakmuran Bersama 2030, WKB 2030. And among the outcomes, by 2030, the main targets would be, there are a few items there, covering quality of life. For example, the target is to bring Malaysia to higher Wellbeing Index, to the score of 136.5 from the base index of 100 from 2000. The other item will be the healthy life expectancy to be increased from 67 in 2019 to 72 by 2030. Also, one of the outcomes that I wish to highlight is on the local capabilities, which is the target is to increase 30% of overall productivity from 2020, and also to transform 20% of low and semi-skilled workers to high-skilled labor. Next will be for the teachers in the teaching and learning segment to be trained to use IR 4.0 tech. And also interesting is to support more homegrown tech providers. In terms of ecological capabilities, the target now is to increase our position, Malaysia's position in the Environmental Performance Index. We are currently placed at 75, which is quite low. So the target is by 2030 we can get Malaysia up to the level among the top 50 countries in terms of EPI. So those are among the outcomes of 2030, and it contains four major policy thrusts. The first one is to equip the rakyat with I 4.0 knowledge and skill sets. Number two is to forge a connected nation through digital infra development. Number three is on the regulations itself to be agile with any technological changes, which is very important. And number four is to accelerate Industry 4.0 technology, innovation, and adoption. There's a special statement on Tvet itself, because stated there in the policy that the policy will focus on enhancing the design and delivery of I 4.0 related courses in institutions of higher education and Tvet, and focusing on the policy thrust of equipping the rakyat with I 4.0 knowledge and skill sets. I would like to highlight the three of the strategies. Number one would be industry-led upskilling and reskilling of the existing workforce for the 4IR or Industry 4.0. Number two is to match the talent pipeline with the future needs of the economy. Number three is to equip the future workforce with 4IR skill sets. So this is in line with the program that we are offering, which is the CR 4.0 monthly talk that starting today as the first series. So as I mentioned just now, we will, even though we are starting with Tvet for the first series, we will be inviting other industry players, even from the government side, to present, to share their knowledge on the CR 4.0 implementation. So we hope that you will continue to support the monthly event by us. I continue with the policy. The five fundamental tech that's being highlighted in this policy: AI, IoT, blockchain, cloud computing, and advanced materials and technologies. And there are 10 sectors that are being in focus in terms of the implementation, with 6 supporting sectors. Of course, if you're talking about modern construction, manufacturing is a key element in modern construction, especially when we're talking about IBS or prefab construction. And of course, transportation is also related well with construction industry itself. And if talking about Tvet, education is being highlighted in the policy as one of the sectors supporting the socio-economic needs. And also highlighted here is the professional and scientific technical services. This is also crucial because at this moment we know that the response from the students towards entering STEM and Tvet related courses are currently quite low and dropping each year. So this is also one of our contribution to the industry. We would like to share more about construction. We'd like to share more that we'd like to share more with those involved in the education industry, to share that in the construction industry is not boring industry without usage of tech. It's not an industry without the usage of tech, but it is no more brick and mortar industry, but instead construction industry is using a lot of tech in the execution of the projects. even though construction itself is being placed as one of the supporting sectors, but in terms of, as I mentioned just now, in terms of the modern construction industry, we'll be looking at also the manufacturing and transportation. So all of this actually contributing to the overall construction industry. Because one thing about construction industry, even though the contribution to the GDP is about 4 to 5% only per year, but construction industry has what they call as a multiplier effect, which means that every ringgit spent for the construction industry actually contributes to the total of 2 ringgit to the Malaysian economy, because construction industry also involve various sectors in it. Okay, next I'll share you about the Kerangka Kerja Tvet, which is the main reference master plan for Tvet in terms of IR 4.0. The plan is for 2018 and 2025. The challenges for Tvet, as we know, is the mismatch with industry demand, the perception towards Tvet, the dependency on foreign labor, the lifelong learning for continuous skill development, as well as the IR 4.0 workforce itself. So through this Kerangka Kerja Tvet, the government has actually came out with 6 major trusts with 11 strategies, and contains 19 major initiatives as stated in the slide. Also important is the graduate employability. So before that, it is important for the Tvet institutions to provide the students with the relevant skills and knowledge in emerging tech for them to be ready for the industry. And also important is the development of the teaching and learning professionals, the lecturers, the teachers in the industry, for them to ensure that the targets are met. The next plan is the next master plan that I'd like to share is the Construction 4.0 strategic plan for 2021 to 2025. This is the master plan that will be leading the Malaysian construction industry to be the leading Construction 4.0 country in the ASEAN region. And also the main mission is to transform the Malaysian construction industry by empowering smart construction for future society. So with that, 12 technologies have been identified. 6 of them are for the short term. Number 1 will be prefab, which is IBS. Number 2 will be building information modeling, BIM. Number 3 will be autonomous construction. Number 4 will be AR and VR. Number 5 will be cloud and real-time collaboration. And number 3, 3D scanning and photogrammetry. As we can see from the players that are already in the market, actually, these six technologies are actually the most common in the market, and we can say that the most ready solutions that are supporting the industry. So the idea is to for the industry to follow through, for more players to come in, and for more players to utilize these 6 tech for the benefits of construction industry. For the medium term, it's less than 3 years, 1 to 3 years. The aim is to focus on the big data and predictive analytics, and of course, T.S. Sharul will share on the machine learning later today. Besides big data will be the IoT, okay, which is placed at this moment at the medium term segment. But of course, there are also ready players in the market who are already providing these solutions to the industry. But as mentioned, the government would like more players to come in and more usage of this solution for the benefits of the nation. For the long term, will be 3D printing, or rather the additive manufacturing. Um, the second one will be the advanced building materials, blockchain, and AI. Again, there are also players in the industry, but for construction industry itself, there are still rooms to be ventured and to be developed. So these are the major focus area as highlighted in the Construction 4.0 Strategic Plan 2021-2025. So I proceed now with the construction tech itself. Uh, the first one will be IBS. Okay, these are the selected construction tech that we believe that will be essential for the future workforce. Definitely for IBS, for students, for those who are graduating, for the new workforce, you need to know about IBS because this is the future, and this is being actually it is already a focus, being made a focus by the government since almost 2 decades earlier. So the first roadmap was in 2003, and at this moment, after 18 years, IBS is already being made compulsory to all government projects, 10 million and above, with 70 IBS score. And for private projects, the government have actually declared and instructed the states to use IBS or to implement IBS by virtue of making it compulsory through building plan submission. So for projects 50 million and above, you need to have IBS score of 50 score and above. And of course, we're talking about IBS. We're talking about the 6 major types of IBS. You need to know about precast concrete. You need to know about blocks. You need to know about steel frames, timber frames, formwork systems, university systems. And again, when we are talking about IBS, it is not just about construction at site, but now we are talking about manufacturing, transportation, and installation at site. And as mentioned, Engineer Ng will share about the advanced precast concrete manufacturing later today. So these are the items that we need to know about IBS. It's important to know. And besides that, you need to know about the standards. You need to know about the MS 1064 standard for modular coordination. You need to know about CIS 18, 2018, which is the IBS score standard. The standard to guide you in terms of determining the IBS score for each of the buildings. You need to know about CIS 24, 2018, which is the standard for certification of all IBS products in Malaysia, which is called the IBS Manufacturers and Product Assessment Certification or IMPACT. And as mentioned, IBS is already in the government policy through the circular by Treasury, and also recently, about 3 years back, it is also being embedded inside the Dasar Perumahan Mampu Milik Negara. In terms of design, is being mentioned that the design of all affordable houses in Malaysia need to use IBS and BIM. Okay? And following through BIM, or Building Information Modeling, this is also important. The process of BIM. Okay? Of course, we are talking about BIM, you're talking about software, but you need to know about the process of BIM. I'm glad to know that BIM is already one of the subjects being offered at polytechnics, but I really wish that IBS and BIM subjects are being embedded inside the compulsory topics of the syllabus rather than additional topics or add-on topics. I would prefer that, I would suggest that IBS and BIM is being embedded inside the main syllabus itself. Okay, again, back on BIM itself, beginning RMK 12, all JKR projects will require contractors and consultants with BIM knowledge. You need to submit your proof of your BIM knowledge, your certs, this example of your BIM models, your list of software and hardware, and your manpower. So beginning RMK 12, all government projects will be focusing on BIM. So you need to know BIM. This is essential for the future workforce. So new graduates, if you come up with BIM and also IBS knowledge, it'll be better for you, much better. BIM itself is also being, it's not already being made compulsory for private projects, but it is being linked to IBS score calculation. In the part 3 calculation of IBS score, referring to as exercise 18 2018, if you are using BIM models for IBS score submission, for level 2, you will get 3 points, 3 IBS score, 3 out, 3 for level 1 and 6 for level 2. So 6 out of 30 of the total part 3 is huge actually. So it is essential for you to be able to understand BIM. And I'm glad to share that we already released our BIM-based IBS score calculation, which is called IBS score for Revit. This is our first edition. Even though we have our own BIM software, which is called TFIM BIM, which is being amended with the Malaysian standards, MS 2522, MS 1064. But for the first edition of the BIM based IBS score software, we release it for Revit because, as we know, the main users of Revit, the PWD or JKR. So for the first issue, we are releasing it for Revit, and of course, we will be releasing it for TFIM BIM and for other brands later. Next will be the other construction tech, for example, the autonomous construction, including the autonomous vehicle, 3D scanning, cloud collaboration, AR and VR, big data, IoT, blockchain, artificial intelligence, additive manufacturing, and advanced material. So these are the other 10 items or 10 emerging tech that are being mentioned or being focused in the CR 4.0 strategy plan 2022-2025. So for both students and academicians at the Tvet level, it is best for you to focus on these items, either through the enrichment of the syllabus itself, or the opportunity for the students for internship, or even for your internal R&D. So the focus are these 12 imaging tech. So I think that's the introduction that I've just presented to you. And of course, for the next session, I'll be inviting Engineer Ng, the Director of IBS Technology Solutions, to share more about the automated precast manufacturing, to be followed by TS Sharul Fitri on the machine learning tools. So again, I would like to invite questions from the viewers. You can actually write your questions at the comment section of the Facebook Live Binatech, as well as the Espo Maya YouTube live channel. So you please share your thoughts, or you can ask a question directly. Try to answer during the Q&A session. So again, thank you. So I'll be passing the session to Engineer Ng. Thank you.
Thank you, Engineer Sharul. First of all, let me share the slides. Can you see my slides?
Yeah, I can see.
Okay, good morning, everyone. Engineer Cheryl just now spoke about IBS. IBS is a form of building industrialization, whereby building components can be manufactured in the factory, especially precast concrete. It also involves both precast concrete for infrastructure as well as precast concrete for building elements like structural elements and walls. I like to visit factories. In fact, I visited many precast factories all over, even Europe, Germany, and in China and Southeast Asia. So I will try to attempt to summarize my personal experience on this automated precast manufacturing. First, the content of my talk. First, I will try to explain what do you mean by automation and smart manufacturing. And thereafter, I will try to summarize the different types of precast concrete production systems based on my personal experience. After that, I will also move on to touch a little bit about concrete production and the delivery systems. Thereafter, if you are managing a precast factory, for example, precast concrete factory, what do you need to do? What are your responsibilities? And it will be the ending will be on the effects of automating precast manufacturing. What are the benefits? What are the benefits we get? Okay, first, automation. What do you mean by automation in relation to precast concrete production? Automation is actually the use of equipments and technology to replace human being. That means to take over manual labor force in preset processes to produce the precast concrete element. So these are techniques and processes that help you to improve the productivity. That is the efficiency, reliability, quality, as well as the speed. Okay, for smart manufacturing, the word smart involves some kind of cyber physical system, right? Cyber physical system. It is something closer to the IR 4.0 or construction 4.0, as mentioned by Engineer Cheryl. So smart manufacturing means you digitalizing and integrating the manufacturing process with a very high level of adaptability to changes. In the previous industrial revolution, in IR 2.0, we spoke about standardization and mass production. But now in IR 4.0, it can be also, we can also, what do you call that? Customize. It can enable us to customize very fast, different product that can come out from the same production line, other than the mass production. So we can achieve significant value by leveraging on IoT, cloud computing, as well as some analytics solutions. So in my personal opinion, the level of automation in a particular manufacturing system in relation to precast concrete production can be classified into three different categories: high, medium, and low. High level of automation means the automated equipments or robots in the whole production processes are mechanically as well as digitally integrated. So the whole system is fully integrated. It's sort of a cyber physical system, something that is very close to IR 4.0 kind of production system. So medium level of automation the individual machines may be automated, but then the whole system are not linked up yet. Okay, those with low level of automation means like very manual kind of casting of PC elements from individual molds, individual stationary molds, and just manually cast. Those are considered low level of automation, or no automation at all. Okay, based on this classification, I try to summarize the different type of precast concrete production systems into a table shown here, and I try to classify them whether they are high, medium, or low level of automation, and also based on each system of production, what are the precast concrete products that can be produced with this method of production. Okay, but this table here, I have excluded AAC production, autoclave lightweight concrete production, and PPVC assembly. PPVC is those prefabricated pre-finished volumetric module, volumetric construction. Okay. So the individual system I will try to explain in more detail in my subsequent slides. Okay. They are as listed in the middle column there. So I'll try to explain them one by one in my subsequent slides. First is the so-called pellet circulation plant, or we call it carousel system. This is the one with the highest, this is one that is capable of giving the highest level of automation, because here, in fact, instead of we put the mold down there stationary, the molds are made to move. The molds in the form of pellets, big steel pellets, flat pellets, where you have maybe 40 of them in the whole factory, and they are made to circulate around to each production stations. First, maybe your production station for plotting, putting site forms, and putting in the casting item, putting in the steel bars, and you move over to a casting machine, casting station, where concrete are poured in, then move over to the finishing site where you have the smoothing device, then go into a curing chamber to cure the elements. After curing, then it goes to the molding station where the panels are filled up and lifted up into the stockyard, and the empty pellet will be cleaned and recycled back to the beginning again. So this form a circulation of the pellets, and the beauty of this system is that the workers as well as the raw material are stationary in each stations, and just wait for the pellet with the elements to arrive, and it will be fitted in and move on to the next station. So in that sense, if we study time and motion study, it saves a lot of efforts. The individual workers no need to walk around in the factory to waste time. They will be stationary in one station, and raw material also you don't have to transport or transfer from one place to another. It's always at one spot and just put into the element. So this is the most advanced system that presently is having. In fact, there are a number of German firms who started off this, and they can be integrated together with the computerized system. Each station can also be computerized and digitally, and they can be connected together. Yeah. So some of the station in the carousel system these are some of the workstations in the carousel system. First, we have the production control. We have the computers. The computers and the servers need not necessarily be in the factory itself. It can be in the cloud. So the computer and the server are the one that integrate the whole factory, the systems, and instruct the machines, the robots and the machines to operate. And your input data will come in through the BIM and convert to a language that is readable by the computer, and the computer will instruct the whole factory to operate according to what you want. Okay, so the next station will be the cleaning station that clean the pellets, clean the pellets, and then spray in more oils. And a marking station will be a plotter. You know, if you draw the drawing, then this plotter will plot out let's say a wall panel, plot out a wall panel in full scale onto the steel pellets, steel plates, steel pellets. Then it move on to the next station, which is called where the shuttering robot will come in and pick the magnetic side form to put at the sides of the panel. Let's say a wall panel, 4 sides of the wall panel, and also if you have door opening, window openings, that can be put as well. So all the side forms will be installed with magnets that sticks to the base mold, okay, by robots. So while this is happening, mesh production can be produced in a separate machine, a mesh making machine, and transfer over to the pellets. Transfer over to the pellets, and the steel mesh can be laid together with all the casting items. And after that, it moved over to the concreting station, whereby concrete delivery from the batching plant will be delivered via flying buckets. Sometimes we call it shutter, concrete shutter. Flying buckets to come in, and it will be discharged to a chute that is at the concreting station. And this discharging chute will have vibrators as well as sensors to regulate the opening of the concrete onto the molds. Okay, so if you reach a place where, let's say, there's a window opening and it will be closed, that means no concrete will go in. So all this will be automatically controlled, and the right amount of concrete will be discharged onto the element, the panel to be precast, and thereafter you have vibration and consolidation of the concrete. Then it moved forward to the next station, which is smoothing station, whereby you have smoothing device. Sometimes we call it helicopter, to smoothen the top surface before and after the concrete setting, to make sure that it is really flat and smooth. And thereafter, the pellets will be stacked up into a curing chamber. In a very modern kind of carousel system, the temperature of the curing chamber will also be regulated to make sure that you don't overheat it. You don't overheat the elements to maintain a curing regime. Even a curing regime can be plotted out, can be measured and plotted out. And of course, based on first in, first out system, after the concrete hardened, then it will move on to the molding station, whereby the whole pellet will be tilted up to almost vertical, and the wall panel will be lifted up. And then the empty pellet will be circulated back again. So this system is actually very, very efficient and very fast in terms of production, and it is very suitable for producing wall panel, floor slabs like half slab. And the same concept can also be used to produce tunnel lining. tunnel segments, whereby the segment molds will be mounted on a pallet and move around. And also for railway slipper production, this carousel system can be used. So the same concept can be used. So the whole system can be integrated by computer, and it is very fast and very efficient in terms of production. In my personal opinion, carousel system is one that is the highest level of automation, highest level with there is something closer to IR 4.0 kind of process. Okay. So the next system will be called the dry cast by vibration and compaction. Dry cast doesn't mean that the concrete is dry. The concrete has very low water cement ratio. That is very dry, but there's still enough water for hydration. So this system, basically, by the name it suggests, is it compact the almost dry concrete by vibration and some of the machine, in addition to compression. It compress it and then vibrate it. So the concrete element become very, very strong. Really. So the heart of this whole process, it can be used to produce like paving blocks, pavers, or concrete masonry unit, hollow blocks. So it consists of a main machine, like what is shown here, CMU machine or the paver machine. Both are actually quite the same. Or one machine can produce both products also. Then that is the heart of the whole production. Of course, then you have other parts of the factory, like for example, concrete production, conveyors for the pallet movement of the pallets. Empty pallets will go in, and then you stamp and vibrate the product, and once it's out, then it's transferred to another rack for curing, and after curing, then it will be the product will be sent for palletizing, stack up in a pallet form, and the empty pallet will be recycled back to the beginning of the process again. So this system is also can be integrated and can be mechanized and integrated together with the different station. But it all depends on how automated is the design of the whole processes. Sometimes you see forklifts shown here. Sometimes you see forklifts here. Forklifts are those that also to help up instead of the pallet travel automatically. We have some more semi-auto way of using forklift to transfer the product, to move the product around. So that's why forklift is used. So the level of automation depends, So on the right-hand side is one that is used for covered production, box covered as well as pipe covered. Basically, it consists of a machine that compact, vibrate the concrete which is in the dry form and is cast vertically, and also another machine which is actually the batching plant. The batching plant produce concrete and deliver over to this machine that can produce pipe cover and box cover. It consists, like for example, in the case of box covered, it consists of a vibrating table below. And in the case of pipe covered, the vibrators are hidden in the inner form, and it can compact it vertically. Another system of producing the precast concrete is the so-called long line prestressing system. By the name, it is very long. Like for example, in the case of hollow core slab production, the length of the bed is 120 meter, or sometimes can be as long as 150 meter. Why we we need it so long. The Holocaust slabs, like for example, Holocaust slabs of planks can be produced by this bed, and they are pre-stressed, pre-tension with pre-stressing strand. So there are two advantages of having a very long bed. First, the pre-stressing force is measured by elongation of the strand or the wire. Okay, so if we measure the elongation over a long distance, 120 meter, 150 meter, the measurement will be more accurate because the elongation will be more. Compared to over a very short distance, they say 10 meter, the elongation won't be so much. So the accuracy is not there. So the long line will give you better accuracy. Okay. On top of that, the front end and the back end of the strand that is cut away will be wasted. So over a long line, the two front end and back end, the wastages will be smaller over a long distance. If it is short distance, little bit wastage before and a little bit after, that will be a lot. The wastage percentage will be a lot. I mean the wastage of the strand or pre-stressing wire. Okay. So this system is very suitable for hollow core slab production or plank production, whereby machine can actually run on the bed, 120 meter long, and the machine can make use of either extrusion method or slip forming method that produce the whole slab all the way 120 meter, and whatever length you want, you just cut. You just cut it across by another saw cut after when the concrete is hardened. Okay. The same concept can also be used to produce, let's say, pre-tension bridge beams. But in the case of pre-tension bridge beams, it will be shorter, not so long. Also, the same system can be used to produce railway sleepers, for example. Railway sleepers also can be produced over a long line. In addition to, just now I mentioned the carousel system. So there are two ways to produce railway sleepers. Okay. Next one is on the spinning method. Actually, the spinning method, the technology is not new. As far as I know, in the 70s already, I see there are spinning machines around that spin. Actually, the spinning machine, the concept is very simple. You have rollers. These rollers are driven by electric motors at high speed. And if you have a mold that rests on the roller, like here, a mold that rests on the roller, it will make the mold rotate at very high speed. So if you introduce concrete into the internal of the mold, this concrete will be thrown out by centrifugal force, and it will be stuck near the inner surface of the mold, and it becomes very hard. At high speed, then it can become very hard. So this system is very good in producing spun piles, for example, pre-stressed spun piles, for example, and can be also used to produce pipe covers. But in producing pipe covers, you can actually produce two pipes at one go, a double pipes kind of a machine. That means there are three sets of rollers, and you can produce two pipes one go. But the production of pipes will be quite slow. One pipe may take 20 minutes or 25 minutes to produce. It takes time to spin. In the case of this spun pile production, you can integrate the whole system together with the batching plant, the handling system, the curing system. Everything can be integrated. Then it can be very highly mechanized and very productive kind of factory. Okay. So this is the spinning method. The next system is so-called packer head method. Packer head method is very useful for producing pipes, smaller diameter precast concrete pipes. And they are produced vertically by quite dry concrete. And the concrete is being discharged from the top of the pipe, here, And inside the pipe, there is a packer head that is rotating and pushing the concrete to the outside to stick to the inner surface of the mold. So the packer head will be rotating at quite a high speed and pushing all the concrete to the inner surface of the mold. So as you discharge concrete into the pipe, the packer head will push and it move up, and the whole pipe will be done up very fast. Each pipe can maybe 2-3 minutes. You will get one pipe done up, and all you need is 2 sets of molds. Like in this case, 2 sets of molds. One set that fill up already, then the forklift will transfer this out to the curing area and open up the mold. It is open out and demolded almost immediately, and open up the mold, left the pipe there, and the mold is closed back and put in the rebar cage and bring back to the casting station again. And once it's bring back, the other mold may have already finished production, and the forklift can remove the other one out, and this one will rotate, go in again to be filled up with concrete. So this packer head method is a very efficient method of producing pipe covers, and it's very efficient and very fast. Next one are those system molds or some very special kind of molds. First, we have the so-called battery mold. You know, battery has all many slots. So each slots can produce wall panel, flat wall panels. Each slots. So each time we can produce many pieces of wall panel vertically in one go, and because we cast the element vertically, we lift it up also vertically. So in lifting out the element vertically, you can lift it up very early, even though the concrete strength is still quite low. We can lift it up quite fast. Next one is tunnel segment. Tunnel segments are this type of mold, the molds with vibrator attached to the molds below. So this is used for producing tunnel segment. This one, the volumetric modules. Volumetric modules are used for the PPVC. I think more importantly is there's an inner mold inside here. How do we open up the inner mold? And how do we cast the top slab and the bottom slab? Because you cannot cast all the six sides all in one go. The other system molds will be the other molds like beam molds, where you can adjust the length, the width, and the depth as according to your design. So the mold can be flexible in adjusting the dimension. The other mold that is used for manufacturing of segmental box girder. These are very huge molds, and they can be operated on hydraulics and running on reels. Okay, static production system is the most primitive kind of production system, whereby a mold is just sit down at a particular place, and all the raw material and the workers will be there to produce the mold, to produce the element out, and after production is discharged and the element will be moved out, and then the mold will be closed and produced again. So this photo shows some staircases being produced, but it can be used to produce many other type of elements, like even beam, columns, and even let's say a SAM or a volumetric module. So by the name it suggests, that means the mold is sitting down there, in one place, fixed in one place. Okay, we'll touch a little bit on the batching plant. Modern day batching plant actually has gone very, very automated, and we don't even need to see the conveyor belts and all those. There's no payloader everything will be, in fact, the raw material is when the lorry come in, will be tipped underground, and then it will be brought up by a bucket elevator to store in silos. Even raw material will be stored in the silos. And production will be controlled by a computerized system, where this computerized system can be linked to even to the suppliers. The suppliers can even troubleshoot the production system. And this is a concrete mixer and delivery of concrete by so-called concrete shuttle, and the casting by casting chute. And in addition to that, concrete batching plant we can also add in a lot of other things. You have the mixture dosing, moisture sensors to sense the moisture content of the aggregate, and different silos for GGBS, microsilicas, and PFA, even fiber dosing for fiber concrete. And even you can put in a chiller or ice break machine to bring down the temperature of fresh concrete. So of course, other than that, you have a fully equipped lab. So in managing production operations, assuming you are a factory manager, these are the responsibilities. Being a production manager, you have to ensure that, the facilities are well maintained, the processes are correct, and the raw materials are there, hand tools. You make sure that the workers are there, how many hours to work, and how is the productivity, how's your cost, what is the break-even volume, and we make sure we maintain. Other than that, of course, we talk about quality management, ISO 9001. We will also have to be concerned about safety and health and the environment. Nowadays, with COVID-19, we have to take care of the health aspect, the SOPs, and then some regulatory compliance to the SOP to meet the authorities' requirement. So these are the responsibility of a production manager. So in production planning, a factory, actually, the production system is very important. The planning is very important in the factory. First, from sales projection, the confirmed job or about to confirm job, and based on the schedule and offtake, we can come up with the loading to the factory, and then we plan out how much to produce based on the loading. And we have to make sure that we have enough resources like raw material, manpower, equipments, and make sure the element after production, there's enough space for the stockyard to keep it. And how can we trace the elements? There may be thousands of elements. How can we trace the elements? Each specific element will be assigned a certain code using either barcode or QR code. Okay, and to deliver out, we have to make sure what kind of lorry is suitable, what the sequence, which elements to go first, and things like that. So the whole thing, in fact, can be integrated in the computerized ERP system. Some of the software vendors, like for example, SAPs or Erica, they can have softwares that can customize to your need. And then you can integrate this whole system together. And on top of that, we can even integrate other parts of the company. Like for example, you can attach your design section, your design. You can attach the HR and admin to compute the working hours of workers, OT, and things like that. And you can also attach the finance and accounting systems. So procurement system. So the whole system can be together to become a very complicated ERP system for the whole company. Okay, so this is my last slide. The effects of automation. As we go towards IR 4.0, of course, there are a lot of benefits. We get very consistent quality, very consistent, very good finish, but with reduced manpower, less people working and for higher productivity. But of course, less people, that means we have to look for, we have to be retrained and look for some higher level jobs, some other higher level jobs. And the whole system can be very efficient and less errors and more certainty in planning. And machine can work very long hour, machine can work long hour without tired, is it? Not like human being. Human being will be tired, is it, after certain number of hours. Of course, the drawback is that highly automated equipments and factory production systems, the upfront cost, investment cost is very, very high. And of course, it will need to produce a lot. Your production volume need to be very high in order to shorten the payback period. So, and also, of course, these are complicated equipments that we have to pay attention to make sure maintenance is up to date. So with that, I thank you very much for your kind attentions. I will leave the question and answer to the end of this whole session. I will like to pass over the floor over to T.S. Sharul Fitri. Thank you very much.
Thank you, Engineer, for the very, very informative sharing of the automated precast manufacturing. In fact, I was during my early days as a fresh engineer. Actually, I managed to join a company which used Krauser system in producing house slab, precast house slab at that time. So it was really interesting to look at the evolution of this system back in late 90s, in 97, 96, 97. The system is already there, but the AI system is mainly controlled by DOS at that time, not Windows, and of course not BIM. It was all 2D CAD, and we had to use diskettes, the 3 inches diskette, and we brought the files from our HQ in PJ down to Seremban for the casting. So that's the moment. Now we have automated, we have robotics, right, in the production. So our next, thanks again, Engineer. Our next presenter, T.S. Sharul, will share more on machine learning. This is also a very interesting topic because now is the age of data. Data is a new goal, right? Data is the new goal. If we have the data, if you manage to use the data properly, we can be the leader in our own industry. So, without further ado, I pass it to T.S. Sharul. Thank you.
Okay, thank you to my friend I Sharul, and also the speaker I Eng. Okay, my name is T.S. Sharul from UiTM Penang. So today I will talk something about machine learning, especially in the construction projects. So I will share my slides. Okay, this is my talk will be talk about, and I will narrow down my topics to construction works, where we can digitize our construction works, especially in the operation at sites, by using IoT things, which is the computer visions, voice recognition, and we try to use machine learning to give benefit to the construction industry itself. And my name is T.S. Sharul Fitri from the School of Civil Engineering, is a College of Engineering in UiTM Penang at campus Permatang Pau. Okay. Okay, before we start our talk, I just want to impose you 3 kind of questions so that we can to think about. Okay. So my first question to all of you, during this now lockdown, and also now I think some of the part of the country now have PKPD. as well also in my state in Penang, some of it have KPD. So as an owner of the business on the constructions, project managers, or maybe you are site engineer on that site. So do you have instant visibility to all of your project data? Because you need this data instantly when you want to perform decision on your projects. And I think most of you know about what is the pertinent data that you need. So some of it is listed on the left side here. You need what is the progress of the project, how the work is progressing, is it according to the schedule or not? Is it the progress is okay or not? How the performance of the work, is it bad or is it now progressing or is it now pending? And how about the safety and the compliance to certain regulation needed on the site to your company? So you need this data instantly somehow in order to make some decisions. So as I shall say that data is a very important now, is a goal because if you have this data instantly to your eyes, then you can make decisions. So the problem now in these days, especially now we have the lockdown and also the PKPD. So most of the construction industry, especially at site, have to delay their work or have to limit their staff. And some of the data is with the person at home that cannot do the work at the site and get the data for you. So this is a problem because the data should be with you 24 hours per day and you need the data 7 days per week. So this is my questions that you have to answer. My second question that you have to think about will be something like this. If you have that data, is it the data is truly connected to you? So this is another problem, because maybe you have the data from the other person that you rely on site or maybe at the site office. So is it that data is truly to your accessibility? So let's say you have one engineer here, maybe at site, okay, the data is with her. Maybe the data on the progress report, what is the schedule, what is the cost, and so on. But is it connected to you directly? Maybe to the top person here, okay? Or is it truly connected to you directly? Even though the data is there, but is it connected to you? This is another problem. So my third question to you, is that data is enough? And if the data is enough, is it scattered? Or is it unstructured? So meaning that, let's say the same girl here, the same engineer here, have the data, but the data she put a lot on a lot of places. It's scattered. It's not structured. It's not manageable. So maybe the progress report is at her office. The truck arrival record is left at the site office, and maybe the COVID-19 she cannot come to the work. Maybe she's not healthy, and maybe she's not permitted to go to the work according to the schedules, and so on. Another reasons. Maybe the safety issue records in the computer in his car. So all of this data is scattered and unstructured. And the bad thing is, I forgot where I put my data. This is a very bad thing. So in order to answer these three questions, especially in this event, we need a kind of automations. And that automation that we call as machine learning and also IoT. So that will be a new thing for us. And that's why my presentation is more on awareness rather than implementation, because I think that from my observation, we have a very low implementation on using machine learning and IoT on our construction sites. Okay. So this is a data that is taken from Europe, from a company, FMI. So they found that all the captured data, 96% of the data captured by industry is not used. It's not so used in the industry. They just get the data. Maybe 4% will be used in the industry and 90% is not used. So it's a wasting of time. So you waste a lot of money, you waste a lot of time to gather data, but only few of them only is only usable in the industry. And 90% of the data is also unstructured. Only 10%, some of the company have a very well record management, but most of them have not using a systematic approach to structure the data. And 30% of the construction teams working hours are spent looking for the project data. So you have to maybe to engage a management person or your crony or your cloud of works, your management team to do this work, but only 30% of the working time are spent on this project data. So why not we solve this problem by using automation? And you know that data is a very important today, because if you are not having a good data, then your company is not survive, especially in this event today where we have COVID-19 pandemic and so on. And we have to need to this data because you have to turn that knowledge, your data, into your action at your site. So how to solve this problem so that we can use our data in a more usable way. So that's why we have artificial intelligence. It's a subset of our machine learning that can improve our construction projects. So when I said construction project here, meaning that the construction project that you have to use in situ construction rather than to use cast fabrication. So, but also the technology can be used also in the precast, especially in IBS construction, where you can monitor also the progress. Okay, so what are the 7 advantages of artificial intelligence? You can use artificial intelligence to mitigate safety risks. So especially if let's say you have a work that is using a lot of equipments that may impose danger to person who are using it. So you can detect the object and you can track where is the movement of that object. Especially if you see on this picture, you can monitor this bulldozer that is trying to scraping the soil, and the technology can detect the movement and track where the equipment puts their soil. Is it to the dangerous area or not? And if let's say the system detect some dangerous action, then the system can give alert to the required project manager there, either to be remote or on site, so that they can have some action to move to do some action to get outside from the danger. The second advantage is to avoid compliance violations. So as you can see that AI, so this technology, artificial intelligence, will use certain sensors such as camera video that will be installed on certain place on your site, so that it can give you some monitoring on any movement, any object, or any event that is done on your work site, so that it can give you some alert. What is the violation that has been done by your workers or by your equipment? So that this is also very important to avoid potential penalties and injuries, so that you can reduce the cost of solving this problem. The third one is to manage suppliers. So if, as you can see that, as I said, your site will be having a lot of material handling comes to your site by lorries or by certain vehicles that go inside and outside from your site. So you can monitor what is the time of arrival of the trucks, what is the plate number, what is the material has been bring over to the site, okay? What is the driver? So this thing is done by a camera, so you don't need any human being to monitor this. And this is a very good way nowadays, especially you are working in the new SOP where you have to limit the number of staffs at site. So by using this system, you can detect what is the schedule of your truck so that you can have the records and the evidence to you. So this kind of data in actual from first advantage until this third advantages will be recorded in the cloud. So this data will be stored in the cloud. So the data will be structured, and the data is also accessible to the managers, so they can have instant visibility to the data and then can do some actions without to go to the site, and they can do certain kind of decisions. The fourth one is to avoid schedule delays. As I will give this one video on this, where you can monitor the progress of the site work, and also the camera also can categorize where is the part that have been finished with the steel installation, especially when you construct a slab, where the work is concreting, where the work is not have any concrete, is there the brick layer has been done or not, and so on. So this can be done by remote camera monitoring that I will show you after this in one video. So by monitoring this, the system will collect all of the data. All of the data will be stored in the cloud, and the managers or the client or maybe the engineers can view the data instantly as long as there is a good internet connections and the camera is still working on that time. Prevent cost overruns. So as I said, because we can monitor a lot of things on site remotely by this technology, so we can prevent a lot of costs that will be incurred by a lot of aspects. And this is a very important, especially when you have disputes between parties on site. So by giving the videos, giving the fact and figures to the people who are querying about the work, so the managers can give a very clear proof to the person, maybe your subcon or mancon, and they can see the facts in front of them, and this will give you a good your credibility to your work, because you can make a very true decision on your disagreement. And the last one will be to improve the security. So I think most of the site have the security features installed, especially the camera, but this system also can do the same thing where they can detect the movement of the object. So maybe the object is due to the burglary and so on. They can see also, is there any material there from certain amount now to be left because of some people moving it. So you can capture a lot of data just by using camera, and also by using artificial intelligence technology. Okay, so this is what we the requirement or the harapan from the CIDB, where they want to have in future from 2021 2015 the master plan. This is maybe what we can do on our site, where we can install the machine learning equipment plus the IoT on our construction sites. So we can have a smart construction sites where you can install these simple tools such as cameras that can record live video, so that you can detect the movement of the object. And we have also to install some internet, I think the fast internet facilities, infrastructures, and other some simple sensors such as images that you can put on the helmet of your staff, so that the camera can recognize whether they are the staff inside a site or not from the site. So they can classify the people who are coming to the site and people who are as a guest to the site. So this is a very important, because it gives you some data collection methodology to the users, so that the people who decide can get the data instantly, and the data looks structured. And to process the data that you get from these tools at the top part here, so you need some system using artificial intelligence. So this artificial intelligence is an algorithm that has been programmed by the programmers that able to intelligently detect the object and also can classify the object according to the required features from the client. So maybe you want to know, is there the person on the side wearing helmets or not? So the camera can be programmed to look whether the person inside the camera wearing or not the helmet and other safety features. So by using these two systems, by putting your equipment and also using this artificial intelligence, then you can have a lot of decisions. You can have decision on the record of the progress, okay, the progress of your site, whether it's being pending, how many percent of construction progress, the arrival of trucks, as you can see in the advantages, the workers monitoring whether they are absent, whether they are using helmets, is it they are entering enter zone, whether they are following the SOP of the social distancing or not. And also the other features that you can do decision is on the safety and also compliance to certain regulations. So maybe the construction has certain problem on site. So by using the camera, they can monitor whether the problem is already solved or not by using this artificial intelligence. Okay, so this is the two things that you can implement on site by using computer visions and also machine learning. So this is the new thing that you can think to convert your site to be much more smart construction environment. So what is meant by computer vision? Computer vision meaning that you collect your data by using cameras. So cameras is a very simple sensors that have certain resolution and have certain specification that you can buy, where you can install to your sites that can collect all of the data that you needed, and that will be stored to the cloud services by internet. Machine learning is the algorithm that you will maybe engage certain companies that able to detect the features that you want for decision making. So after the features has been detected by this camera, then the features can be extract out from the video and will be processed by the artificial intelligence algorithm. So basically, we have certain process starting from the camera, where it will detect the objects moving on your site, and follow the object that you want to observe, and maybe human being, maybe the equipments, maybe the progress of the job, and so on. And after that, that object will be segmented out. What is mean by segmented out? Meaning that the object will be extract out from the real environment, and they will be located to the computer algorithm, where it will be put inside to a pre-trained deep learning model. Okay, this is a model that will be used to look intelligently your objects, so that a lot of decision can be made. So maybe if you want to make the decision on what is the vehicle types, so let's say the object that you want to detect is vehicles, so you can ask the programmers to create a model to detect what are the vehicle types that is entering the sites. Okay, maybe you want to detect the human beings working, are they using the PPT equipment or not? So that object will be segmented out and can be trained intelligently to detect the usage of PPT and so on. So you can detect work progress, defects on the concretes, the type of workers. Maybe you have certain workers working on the site, and then you want to see whether the workers is coming to your site or not, and so on. And after that, the data will be stored to the cloud. Those information will be stored to the cloud, so that it will be put in a structured manner and easy accessible to all parties needed. And you can put some kind of data analysis. So these features can be programmed by the programmer, where all of the data can be viewed to us to our convenience. So maybe you want to see the schedule of the work, you want to see how many percentage of people coming to the site, whether the person following SOP or not, and so on. So you can have the data analysis instantly on you without to do anything. And it is accessible to the any parties that is managing the project. So this is the flow chart, the easiest flow chart that you can understand on how to use computer visions and machine learning so that you can have decision instantly, and you can have the data structuredly without asking other parties to get the data to you, especially in this COVID-19, where some of your workers cannot come to the office and maybe the data is with them. So sometimes maybe they are the data is not with them at office. So and you need to do the decision now. So it is better to have this system on your side. And this is the where I put the red color is the thinking part of the system, where you put the intelligence. See, this is the brain of the system. The three box on the top here is the collection method, and the three bottom rectangular box at the bottom is how you store the data and analyze the data, and you can make decisions. Okay, so I give you now some overview of the system by viewing the video. So this is I'm taking from Indus. Indus is a company that is in UK. They have already installed the system in the year 2017, much more backward from the COVID-19. So this is, you may see that the camera is taking, observing the objects. You can see observing the peoples, observing the bulldozer, where you can see that you can count the number of workers there. So there are 5 to 4 people detected here working, and you can see the status of the worker, whether they are using PPE or not. So you can see that missing PPE, no issues. So because the camera is now trying to observe online, so some of people maybe is not inside the camera domain, so it can detect it. So some of the result is showing either to be no issues and without PPT. And you can view also whether the working area is according to the plan or not. So this is one way where you can increase your efficiency by tracking the site resources by using cameras. And this is one of the monitoring done on 2017 by Indus, where they can monitor the truck arrival to the site. So hopefully you can see the video. So you can see that all the trucks now is being recorded by this sensor. You can see that there is a sensor here that is tracking the movement of the car. And you can see also the truck license plate is being recorded automatically without manual record. And it counting how many trucks in and out. So very, very smart. So this a very good decision where you want to monitor whether the supplier is doing their work or not to your site. So you can call them to ask them whether why this truck is not yet coming to my site, because you have a good evidence to show to your supplier they are not coming yet. Maybe they are delayed and so on. So you can see that the time and the date is there. Okay. So so from the software, you can also analyze the vehicle type, the time, the license plate, how many total of loads, average load per hour. So a lot of calculation can be done, can be predicted by the system. So this is a very good overview for the contractors where they want to see how the progress of the work of the site. And this is some of the report that you can found from the system, where you can see the historical or the histogram of the arrival. Sorry, the graphic is not so clear because this is the best resolution that I can get from the Indus. Okay, this is a very good features where you can monitor the site progress. Okay, so before I run the video, you can see that some of the floor is marked by the orange color, showing where is the steel bar installation. And the other part is not in orange, meaning that it's still in not yet installed the rebar. So if I click the video, you may see that the progress of the work done. So it can track and can classify the slab, how well the progress has been done. So with certain colors. So you can ask the programmer to use this technology. Then this data can be stored to the cloud storage. So you can see that a lot of the places now has been installed by the steel bar and so on. So this is the analysis of the result that you can get from the video. You can view the histogram of the equipment, what is the progress on the site, truck arrivals, and so on. So this is a very good overview of the work that has been done from certain durations. So because you have to monitor this because of the schedule, because time is money to the construction. And this is one application of the machine learning where you can track the workers' trade inside and outside, and you can recognize whether they are using helmet or not. And some of the helmet has been installed with certain images so that the camera can recognize the image and categorize the image according to the traits that has been registered. So if I play the video, you can see that the trait recognition here. Once the person entering this gate, then you can see that the trait will be recognized. So according to the camera resolutions, it can categorize the trait of the workers and so on. And the time and the date of that person entering the office or outside from the office is recorded. So there's no need to perform or using handprint scan or other else, because that device is only stored, the data is stored to that device only and cannot accessible to you. So you can get the data instantly by having the data uploaded to the cloud. So you can see that the person with the electrician there. So the tree is being shown there because there is an image there that is being detected by the camera. So you can view as a contractor whether your workers are doing your work or not at every floors. So maybe if you have 20 stories, so maybe have 20 cameras to install, and you can view your workers while you have coffee at your home. You have breakfast with your family, and you can do your work remotely in certain sets. So because sometimes also you have to come to the site. So, but at least you are supporting the government regulation that to reduce the number of workers at site. Okay. This is another good view where you can monitor the physical distance SOP, the COVID-19, the distance between your worker at site by using camera. So if I click this, you can see that the camera can label the distance between the workers, whether they are complying or not, and this data will be uploaded to the cloud. And as a manager, you can see how well your workers or your site workers complying the physical distance that has been set by the government or not. This is 2 meters at Europe, and in our country, I think 1 meter. I think. Okay. So you can see that from the camera itself, you can see the workers not following the social distance, and you can mark them with the red colors. So you can see the statistic on that time, how many workers are not following the social distance. So these 3 fellas is following the social distance because they are too close here. So you can ask your supervisors at site to ask them to work following the SOP as the required by the government. Okay, this is my last segment where I want to give you some overview of how to use machine learning after construction. So the slides before is talking about during the construction, but now also you can use machine learning to help you to monitor the defects by using technology called as chatbots. So this chatbot will interact you by voice, and I'll give you one clip from Mac 2. So it's about 5 minutes video, and hopefully you enjoy to view it. I will skip this, and I will show to you.
Mac 2 is the world's #1 artificial intelligence empowering the end-to-end process for the building and construction industry.
With the voice assistant chatbot, Mac 2 supports me anytime, anywhere. Hey 2, are there any activities overlapping with HVAC services in the schedule?
Yes, there is an intersection between HVAC duct system and electrical system installation works.
Please show me the intersection from the BIM model. Please adjust the schedule to avoid overlapping.
Schedule is updated.
Thank you, Mac 2. We can also ask Mac 2 via chatbot to match the best building materials from the product catalog. Mac 2 is not only giving the results, but also provides the analyzed report based on these results with price and quality conditions. With this intelligent outcome, the decision maker can easily decide the best products for the project.
Mac 2 is supporting the safety and quality inspection on site with smart guidance. Hey 2, I'm on the 3rd floor. Please show me the inspection checkpoint.
Hi, Sergey. Please follow the walkway for today's inspection.
Hey 2, Anderson Construction has to repaint the wall on 3rd floor, zone number 2. Add it to punch list with due date next Monday.
Issue added. Floor plan highlighted for Anderson Construction.
Hey 2, Walker Engineering has to fix window on the 3rd floor, room number 5. Add it to punch list, due date next Tuesday.
Issue added. Due date confirmed.
Hey 2, Walker Engineering has to cover electric duct in technical room on the 3rd floor. Add it to punch list with due date next Monday.
Done.
Empowered by mixed reality, Mac 2 can integrate the virtual model with the physical site for precise checking. Hey 2, did we purchase ventilation shaft covers for level 3?
Yes, we did.
Show me the details.
Please see on screen.
Okay, let's take a measurement. I see. There is a defect here. Add it to work list for Anderson Construction.
Defect added.
Thank you, Mac 2. Hey 2, can you call Tony?
Hi, Sergey. Can I help you?
Hi, Tony. Can you please check the power distribution box for this unit?
Yes, I'm checking from my data. This is the electric diagram. I'm sure this is an incorrect installation.
Yeah, I also think so. Thank you. Okay, see you tomorrow.
See you, Sergey.
Hey 2, create a defect for this AC unit and attach picture of power box to it.
Issue added and assigned to the electric department.
Thank you, Mac 2.
The machine learning and deep learning algorithms enable Mac 2 to learn from construction big data. Integrated with the artificial neuron network architecture, Mac 2 is capable of providing advanced planning, problem solving, reasoning, and perception for the building and construction industry. Running together, we build the future for.
Okay. So those are give you some testimony from other company in UK, how is machine learning is performing well to theirs. Yeah? So you can see that a lot of compliment there. Yeah? You can read on your own how well they are using this machine learning. So they have been using before us. Yeah? So maybe we can get their experience later on, maybe from this company through AI Sharul. We can ask them to collaborate with us and maybe they can share later on, maybe. Okay, so for my last slide, so thanks for your attention. And if you have problem, you can contact me or Mr. Sharul itself. Thank you a lot and have a good way. And I will pass back to IR Sharul. Thank you.
Thank you, Tia Sharul. Very exciting, the presentation. Of course, this is the current and this is the new future. It is it is essential for the students as well as Tvet institutions actually to embark on this, because otherwise we'll be left behind. Because please do note that we are no more number 3 in terms of the GDP, highest GDP countries in ASEAN. Actually, we have been overtaken by Vietnam, and their ICT progress is much faster than us. So for us in Malaysia, I think we need to actually really change and embark into this modern technologies, actually, especially for construction, because construction has been actually been sleeping for 30 to 40 years without much progress. So then came IR 4.0 with its solutions, with all these solutions and all. So it is important for us to embark it early, because ICT changes very fast. It is important for Tvet institutions and their students actually to be ready for the industry, not only for the consumption of the for the local consumption, but also for the overseas consumption. Perhaps some of our workers will be professionals overseas, right? Some of us will become consultants overseas or doing projects as contractors overseas. If we want to compete, we need to embrace this technology. I remember at one time when IBS was in the very early stage. It was in 2008, I think, when I did an audit, a construction audit with CIDB at that time. We are one of the consultants. We went to site in Thailand looking at one of the projects by Malaysian contractors. It is interesting to see that the contractor actually that won the job actually constructed the project using IBS, even though they are not using IBS in Malaysia, because they know that if you want to bid and want to be successful in bidding the project, they need to use technology. That was 13 years back, and now I think it's no more in terms of the method of construction, but also the other tools, all those the rest of the 11 emerging tech, which is also important to be embraced by us. Thank you again, Tia Sharul. In fact, Tia Sharul is our consultant actually for our machine learning development. We are offering training, and also we are looking forward to produce solutions in the near future. Thank you so much. So I'll proceed with our last segment before the Q&A segment, which is a short demo of our latest product, which is Expo Maya. We developed this actually to support the training and event industry, which has been disrupted by the pandemic. Of course, we already have virtual events, virtual trade shows and all, but it is all in 2D. But we are now offering a 3D environment in VR actually for us to enjoy the experience of expos, exhibitions in a virtual world. And in addition to that, we also offer Expo Maya, which is to be released later this month. We are also offering this to companies to have their product showcase inside the virtual world. So rather than having the products being exhibited or being displayed at the shops or the factories, they can have a 27 virtual world for visitors to come and visit. Similar to your ordinary website, but in this case, it is in a virtual world, which is Expo Maya. So I pass to my colleague, Sue, to continue with the presentation. Thank you.
Okay, Assalamualaikum dan selamat sejahtera. Jadi saya akan tunjukkan untuk Expo Maya. Okay. Jadi yang ini kita dah masuk ke dalam Expo Maya sendiri, iaitu kita ada 20 booth. Kita ada 20 booth bersamaan 10 bilik. Jadi saya akan teruskan. Okay, first kali saya akan tunjukkan untuk guide bagaimana function keyboard dan function mouse berfungsi. So dekat sini kalau kita klik untuk bahagian kiri mouse, kita akan untuk berpusing. Kanan untuk kita transport dan W untuk kita ke depan, A untuk kita ke kiri, S untuk ke kanan, S untuk ke belakang dan D untuk ke kanan. Okay, contoh saya buat ialah saya klik di bahagian kiri, so dia akan pusing, dia akan round ke sini. Dan kalau saya klik di bahagian mouse bahagian kanan, dia akan transport, so dia akan pindah secara automatik macam ni. So kita tak payah berjalan. Okay. Untuk bahagian A, keyboard di bahagian W untuk kita ke hadapan, keyboard A untuk kita ke kiri, keyboard S untuk kita ke belakang dan keyboard D untuk ke kanan. So kalau sini saya tekan keyboard W untuk ke hadapan, jadi saya akan tunjukkan satu bilik iaitu room 6A. Kita bahagikan kepada 10 bilik. Di bahagian kiri yang kita dah masukkan barang seperti PDF, Tvet dan video. So saya tunjukkan bahagian satu. Yang selain tu kan kita masukkan bahagian bilik lain. Di bahagian kanan ni kita tak ni untuk kostum, maksudnya macam ada customer ke apa, kita akan masukkan. Jadi kita akan pergi ke bilik room 7A, iaitu yang kita masukkan PDF, video dan image. So macam ini ialah contoh PDF yang kita telah masukkan terlebih dahulu. So kita boleh klik, so dia akan show lah. Jadi macam kalau macam gambar ni macam terlampau kecil, kita boleh right click, so dia akan showkan bahagian besar lah. Sama juga seperti video, kita boleh besarkan dia dengan right click di bahagian video tersebut. Contoh macam kita nak pause ataupun kuatkan music, kita boleh pilih kostum ataupun kita pause. Kita boleh repeat lagi sekali. Ini juga seperti gambar, right click. Dan ini ialah contoh 3D yang kita masukkan. Yang ini memang dah ada di dalam Expo Maya sendiri, 3D yang kita masukkan. Jadi saya akan tunjukkan function selain pasukan 3D, iaitu kita boleh interrupt bersama orang lain. Seperti contoh, saya akan share screen. Sebagian bahagian bawah ni saya akan terangkan satu persatu, iaitu share. Share kita terbagi kepada dua, iaitu share screen dan share camera. So contoh saya share screen. Share screen ni function dia sama macam Google Meet yang kita boleh share screen, Windows ataupun. So contoh saya ambil share Chrome, saya akan ambil Meet. So macam kita nak share bahagian orang kata slide ataupun gambar, kita boleh bahagian keluar macam ni. So selain tu kita ada bahagian pen, iaitu please. Di bahagian please kita ada pen, iaitu macam contoh ada pembetulan yang kita nak betulkan, kita boleh tekan lah pintunya. So kalau macam ada apa-apa pembetulan di bahagian gambar ataupun PDF, kita boleh betulkan di situ. Selain itu, kita ada 3D model. 3D model ni kita boleh masukkan 3D model yang ada dalam Expo Maya sendiri. Seperti image. Contoh saya ambil satu 3D model. So just kita klik. Kita klik, just kita boleh pilih bahagian poly ke apa. Dia akan masukkan secara automatik. Maaf, mungkin line saya ada problem sikit. Jadi saya akan teruskan di bahagian change avatar. Avatar ni ialah gambar yang kita nampak lah. Seperti contoh, kita boleh tukar avatar kita yang ada di dalam Expo Maya sendiri. Ataupun kita boleh change ataupun custom avatar kita. Seperti kita kena pergi di bahagian page Expo Maya sendiri. Kita ada create avatar. So dekat sini kita boleh create avatar kita sendirilah. Macam custom avatar kita nak bentuk ataupun warna pakaian macam mana. Dekat sini kita boleh edit lah. So contoh ini custom yang saya dah buat. Kita boleh ubah berbagai macam sekarang kita. So jadi saya next. Yang ini kita boleh custom avatar kita sendiri. Ikut sekarang kita antara yang ini kita boleh custom avatar ataupun kita just boleh masukkan gambar dan dia akan generate sendiri automatic untuk depend kepada kita punya gambar lah. So kita copy, bila kita next kita copy dia punya link. So pergi kepada Expo Maya sebalik. Pergi kepada place iaitu avatar. So kat sini ada avatar GLUR. So kita klik bahagian paste. So apply. So dia akan tunjuklah kita dah akan tukar avatar. Seperti kalau macam kita nak tengok kita dah tukar avatar ke tak, kita boleh ni. So kat sini dia akan menunjukkan avatar kita dah tukar. So contoh yang lain iaitu upload. Kita boleh tukar scene juga, beberapa scene yang kita dah custom. So macam room A, room B kita boleh custom, kita boleh tukar scene. Selain itu kita boleh upload seperti dalam file GLB, PNG, JPEG, GIF dan MP4. So contoh saya akan masukkan satu gambar iaitu dalam file JPEG. Kat sini dia boleh custom lah kat situ. So kita boleh gerakkan. So contoh macam kita boleh gerakkan kalau macam kita nak pin, tangan bagi benda tu bergerak, kita boleh unpin. So benda ni takkan adjust. Jadi macam sekarang itu kita ada reaction. So contoh kita akan pergi ke bilik ni. So saya ni Halim. Others punya ni. So macam kita reaction. So dekat situ dia dapat lah reaction kita. Selain tu kita boleh check boleh interaksi bersama peserta-peserta yang ada melalui chat ataupun share screen ataupun voice. So, contoh macam kita tak dengar sangat suara Halim, kita boleh kuatkan ataupun menikan dia. So, kita boleh interact menggunakan chat dan kita boleh interact kepada voice. Hai Halim.
Hai Su.
Okay. Selain daripada chat, kita boleh voice. So macam pada ni kita boleh buka voice dan kita boleh bercakap dan chat. So contoh ni yang di bahagian kiri kita dah masukkan PDF dan link, PDF dan 3D image. Dan ini ialah bahagian kanan iaitu kita kosongkan. Yang ini kita ada 20 booth samaan 10 bilik lah. So bahagian kiri seperti saya cakap, bahagian kiri kita dah masukkan beberapa contoh document dan bahagian kanan kita akan kosongkan. So inilah contoh-contoh bilik yang ada untuk booth, 20 booth. So seterusnya saya akan tunjukkan kita akan tukar scene kepada scene yang lain seperti yang tadi kita tukar scene di bahagian sini, tapi yang ini kita akan pakai link. So yang ini kita visit room. So kita klik dia akan automatic masuk kepada room yang lain lah, ataupun room yang lain menggunakan link yang sama. So yang ini kita akan masukkan ke dalam construction showcase. So kita first, kalau kita dapat link, kita join room. Kita dipilih antara mute atau tak. So enter the room. So ini ialah room construction. Ini contoh yang kita dah customize untuk semua. Contoh ini interaction daripada Halim sendiri. Kita akan pergi. Kita boleh interact kepada peserta yang lain. So construction ni kita ada 3 bahagian, iaitu BIM, IBS dan IR 4.0. So contoh ini ialah bahagian BIM sendiri kita bahagikan, iaitu daripada Innovasa sendiri punya BIM. Contoh di bahagian gambar sendiri kita boleh letak link sendiri untuk pergi ke web lah. So dalam gambar ni kita ada link. So bila kita tekan open link, dia akan ke link kita, iaitu yang tadi. So contoh yang lain saya cuba untuk yang ni, visit open link. So dia akan pergi ke bahagian link yang kita simpan lah, bahagian gambar. So macam ni kita boleh tahu lah yang lain. So contoh yang ni gambar, kita boleh ke link, dan ni ialah PDF. Kita boleh ubah. Dan ini ialah video macam kita tak nampak. So kita right click. So dia akan keluarkan video yang kita boleh mainkan. Kita boleh besarkan. So next case ialah IBS. So ini ialah IBS. Kita bahagikan iaitu 6 komponen IBS yang kita boleh gunakan. So ini 3D model yang kita ambil daripada Expo Maya sendiri. Kita masukkan ke dalam ni. So kita boleh letak gambar dan kita boleh letak 3D. Macam kita nak instruct sendiri, kita boleh instruct ataupun kita boleh check. So kat situ kita boleh instruct bersama dengan peserta yang lain. So yang selain tu, di bahagian ni ialah IBS dan di bahagian kanan kiri ialah construction 4.0. Sama juga di bahagian gambar kami ada letakkan link. So link tu akan pergi kepada web apa-apa saja. Contoh kita tekan bahagian sini, so nanti dia akan pergi kepada web yang ada lah. Kita boleh masukkan web dan link. Di bahagian gambar tu kita boleh letak link untuk web lah. So dia direct ke sana lah. Yang ni kita customkan kepada 3 bahagian, iaitu BIM, IBS dan Construction 4.0. So kita instruct menggunakan untuk peserta lain, kita menggunakan chat ataupun voice, ataupun kita boleh share screen ataupun share kamera. Dia function sama seperti Google Meet. Dan kita boleh gunakan pen untuk jika macam peserta present dan ada error dan kita boleh betulkan, kita boleh tekan lah. So dia akan betulkan lah. Contoh macam kita nak highlightkan bahagian date. So dekat sini kita boleh tekan lah. Dan kita boleh masukkan beberapa 3D model. Kita boleh custom avatar kita sendirilah, dan kita boleh tukar scene dan kita boleh tukar dan kita boleh masukkan beberapa file untuk kita tunjukkan, untuk kita present, seperti JPEG, PNG dan JF dan MP4 seperti video. Setakat ni ini saja yang saya tunjukkan untuk Expo Maya. Jadi seterusnya saya akan paskan kepada Encik Syarul.
Okay, terima kasih Su. Sharp at 11:30 So now let's proceed with the Q&A session. So in essence, before that, Expo Maya itself, as I mentioned, it is the platform the VR platform, VR event platform that we are offering to the industry. We'll be releasing it later this month. So we are offering for events, for trade shows, for even for your final year projects, exhibitions, and all, as well as for companies to showcase their products. So we'll be releasing the price list as well as the details in the near future. Okay, thank you again, Sue. I will again welcome Engineer Ng and T.S. Sharul to join us for the final part of this webinar today, which is the Q&A session. We receive few questions. We try to answer all. There are a few questions that we captured from the YouTube, Eswamaya YouTube channel, as well as Facebook, and also outside this platform, right? Okay, the first question will be for T.S. Shahrul Fitri from Facebook account owner Zain Ismail. What is your opinion in implementing all these new technologies widely in the construction if there is always budget constraint from the government and client? It's a very popular question. Okay. How can we adapt this with budget constraint from the government?
Okay, thank you, Mr. Sharul. Thanks for the question from Zain Ismail. What is your opinion in implementing all these new technologies widely in construction if there is always budget constraint from the government and client? Okay, we can take this in positive sense or in not positive sense. So for me, if we have a budget constraint, then we can start small and the basics one. So maybe the most basic instrument that you can use for this purpose would be just to install cameras. Okay, you have to install internet infrastructures and some ML system. So that is the basic one, and that is not so expensive. If let's say if you want to compete with all sensors, it's very expensive. So my opinion is to start small and basic. So because by using that camera system and infrastructure of internet and also the ML system, machine learning system, that is enough for monitoring your site, especially to convert your traditional site from normal one to more smarter construction. So I think we can start from small and basics one. Okay? So that is my answer for that questions.
Okay, thank you, Sharul. Okay, for the next question, question for Engineer Ng from YouTube account owner Reham Baidun. The question is, I would like to know how strong IBS system is for high rise, and how tall it can go, and if it is possible or advisable to create a full building from basement to top buildings in high rise. Thank you. So that is a question.
Okay. In my personal experience, I have done frame structure 20 over stories, full frame, full precast systems 20 over story frame structure. Also for wall and slab systems, I have also done 20 over story. But in Malaysian environment, I have seen the wall slab systems being constructed to 30 over story. 30 over story is done. And even as you go taller, I don't think there is much of an issue. As you go taller, in fact, in Singapore, HDB has done more than 50 stories. And even in Singapore, there are concrete PPPC projects of 40 stories being completed. So it's not an issue, but as you go taller, the precast elements will be, especially those at the lower floors, will be bigger and it will be heavier. So your lifting facilities will have to be, you have to install heavier cranes and things like that. Or alternatively, you provide a so-called of let's say for column, you provide a shell outside, and then you cast the inner part in situ. Or for wall, you provide a double wall as a formwork, install and cast the interior part of the wall in situ. That will help to reduce the weight of the element. As far as technically design is concerned, I shouldn't think that there is much of an issue can be designed. Okay.
Yeah. Thank you, Engineer. If I may add, IBS is a method of construction, right? So it is similar design, but you need to do some detailing during lifting, right? During demolding, lifting, and installation stage. As rightly said by Engineer Ng, perhaps the limiting size will be the capacity of the crane to lift the components, hence limiting the story height. For example, I think you mentioned about Duxton, right? Pinnacle at Duxton, the 50-story precast building. At one time, the tallest precast building constructed by HDB. I think it's a very interesting project. And you mentioned about the PPVC project, which is planned to be the highest prefab building in the world, I think, in Singapore.
Yeah. There's 56 story, if I'm not
50 story.
Yeah.
Very interesting.
Yeah. Going to be built is not completed yet.
Yeah. Would you like to share more about PPVC itself? Yeah, in addition to precast, since we...
Okay, PPVC is another concept. Actually, it's a different concept, and the production of PPVC is more like our car assembly line, where eventually we can actually introduce a lot of robots to install building components together, to prefabricate the building components in the factory. So there are two types of PPVC. So far in Singapore, I think also the rest of the world, either a steel PPVC or a concrete PPVC. Steel or concrete actually it is the external shell or the carcass. So either you cast it with precast concrete or you make it with steel panels. And of course, steel panel is lighter, and concrete PPVC will be much heavier, and you need a heavier crane, maybe up to 50 ton of tip loads cranes to lift the concrete PPVC. But the idea is everything inside the PPVC will be complete assembled in the factory, and the PPVC actually also have many stations for the PPVC to be assembled. Say first station, maybe you cast the empty shell first, the concrete carcass first, and then you move to the next station. You provide you put in the, let's say, tiling. Another station you put in the door and window frame. Another station you put in other things, electrical switches, and as you move to until the last station, all the interior works are all completed, including architectural, and you can have a final QC check. And once it's okay, approved, then you can wrap it up and to be delivered to the job site. So in that sense, the building is constructed in the factory, and all the individual components, like doors, windows, lock set, and all those will be delivered from other factories, the suppliers' factories, to these PPVC factories to be assembled together, like in the car assembly line. And it is a concept called DFMA, Design for Manufacturing and Assembly. So the assembly of the components together and send it to the job site to be installed and connected together. So that is PPVC.
Thank you, Engineer. I think definitely that's the way to go, right? that's more closer in terms of prefabrication, more closer to the car or automotive industry, because this also will lead to the supply chain of the final product, which is the PVC itself. And if I may share, CIDB itself has actually produced their own publication as a guide for our industry, which is publication 187, if I'm not mistaken. The viewers, you can check with CIDB. I think it's publication 187 by CIDB. The publication was handled by CREAM, their research arm, which is the publication is about the design guide for PPVC. It's being called volumetric modules in Malaysia, VM. VM. So for those who are interested, you can refer to CIDB for the publication. Thank you, engineer. Okay, we go to the next question for TS Sharul Fitri from YouTube account owner Norina. I think she's Dr. Norina from UIA. Apa khabar? Okay, the question is, can machine learning predetermine dangerous accidents? I think this is very interesting. Perhaps, Sharul, you can give some example, or perhaps the example and also the opportunity for R&D that can be done in terms of providing these solutions. Thank you.
Okay, thank you for the question from Datin Norwina. So, can machine learning predetermine dangerous accident? Yes. It is one of the purpose of using machine learning. Yeah, one of the objective. So I can give you some examples of how to use this machine learning to predetermine the dangerous accident. So we can determine the accident based on three components. The first one is due to humans. The second one is due to the objects. The third one is due to the event. So let's say in terms of humans, so if let's say the human is monitored by the camera that has been installed, the system of internet and also the machine learning algorithm. So if let's say the human does not having or not using safety helmets, or not to use any PPE, so that is one of the reason to start our dangerous accidents, because accidents start from the small reasons, isn't it? And after that will follow accumulated and you get a more serious accidents. So that's how you can monitor or to predetermine the dangerous accident by monitoring the human being that is working in the site of the construction by using computer visions. A second one in terms of object. So object, we have to use a much more expensive sensors. If let's say if I want to monitor the performance of structural, let's say I have a beam that is installed on a beam on a building. If you want to monitor whether the beam is working well or perform well under certain loads, so maybe you have to embed during the construction some sensors such as a strain gauge, and that strain gauge must be connected to the cloud services so that all of the data that is measured by the sensors, which is the strain gauge, can be transferred to the cloud. And from the cloud, if let's say the data is reaching certain threshold value, so maybe concrete, the ultimate is 0.0035. So the signal will comes to the decision maker, maybe the site contractors, and they have some alerts on the dangerous possibility that can happen to the beam. So maybe the contractor can call other people to come over to the site and look at on the possible sections that may have the problem based on that data. So that is the object part. Another part is also on human, because some human also working on the high-rise building. They are having the possibility of risk to fall, isn't it? So maybe due to of negligence or some construction management problem, I do not know. So maybe you can install on their belts the accelerometer. So there's another kind of IoT gadget called as accelerometer that you can install on the belts of your workers that doing the job on the high-rise building. And if let's say the data will measure the acceleration of that guy. So if that data is more than certain value of threshold of acceleration, the signal will be passed to the cloud service and go to the maybe the main con. So the main con knows that there is a possible risk of people falling. So he will go and call the site supervisor on that floor, asking to that person to work well and avoid that possible fall risk events. So that's how you can avoid some dangerous situation, because if the person fall, then the company has to be blamed about that serious accident. And another thing is that you can use also a camera vision to detect smokes, because smokes fire due to fire event. So if let's say the smoke can be detected by the computer vision at certain level of shapes, if let's say very, very small, so it can be detected by that camera, and it can use the data for further action by the contractors or by the workers to do something and to check whether the place having fire or not. So before the fire, much more larger fire event occurs, then we make initial actions by visualizing the signal from the camera that's detecting a very fine smokes on that event. So I think I give you some comprehensive on examples, and I hope I have already answered that question from Datin and from the participant. Thank you. Back to Sharon.
Thank you so much. Next question. I just squeezed in this question, a very short question again from Datin Owina. How many such IBS manufacturers in the country, in Malaysia? So based on the statistics from CIDB, I think the latest one was updated in April 2020, but of course we can refer to CIDB IBS Berhad or the division itself, the IBS BIM division itself. At this moment, it's being recorded that they have about 310 manufacturers in the market and 12,400 contractors. Okay? But bear in mind that not all of the manufacturers are actually doing the so-called heavy IBS stuff. Most of it are actually doing blocks and steel roof trusses, and some of them are actually providing system forward solutions. In terms of precasters that are being able to support the whole project, it is still not many. In some states, even in some states, there are no precasters. So hence the issue of cost, which I would like to answer it. There's one question on cost really later. So that's on the advanced manufacturers. Okay, I shall proceed with the next one. For Engineer Ng, okay, can you share on the possibility of Tvet institutions to be involved in automated precasting? For example, for them, for the lecturers and for the researchers at the Tvet institutions to be involved in R&D, for example, mold design or control system, concrete studies that can contribute to the, can say, more modern method of precasting. For example, the automated precasting. Thank you.
Yeah. The way I look at it, I think, okay, as students, of course, they will become technicians and all this. You have to embrace the latest technology when you come out from the institution to get involved with IBS production and also in the latest kind of digitalization, latest kind of smart construction in the market. What about the teaching staff? To the teaching staff, perhaps, of course, besides teaching the latest technology to the students, they can also undertake research and development that is more related to the so-called construction 4.0, something that is more unique in our local kind of environment. An example will be perhaps like, for example, this carousel system. It was actually developed in Germany. And the European way of construction compared to our Asian kind of construction is slightly different. So the technology more suited to the European kind of environment, whereby their housing is of lower rise, and over here in Malaysia and even Singapore, we have a lot of high rise building. So we can look into research and development into areas that suits our local practice. So this could be one of those that have to embrace new technology. I hope I have answered that.
Thank you, Engineer. Thank you. So we are in the final 10 minutes of our session. Don't forget to fill in your attendance, because each certificate will be provided to you. So the links for the e-attendance, the link for the attendance are provided through the YouTube and Facebook channel. And we will try to answer all questions that are being posted in the channels. But for the final one, I'll take this opportunity to answer this question from Cik Zain Ismail from YouTube account owner Zain Ismail. I've been stated here, I've been involved in construction industry for more than 15 years. One of the objective implementation of IBS is to reduce cost and time consumed on construction site. But in reality, it's vice versa. Any comment? Okay. Again, it's a very popular question on cost. But it is important for us to realize that in terms of time itself, there's no issue, because IBS will really quicken or fasten your construction, because the productivity is much higher. For example, if you need 50 to 20% for one area, but for IBS you only need 4 to 6% that handling one gang of crane. So that's the number in terms of comparison of the productivity. But if you're referring to cost, definitely IBS material cost will be higher, because you are talking about factory production, you're talking about transportation. Okay? But you have to realize that in projects, we don't look at material cost only. We look at the total construction cost, because IBS will reduce the number of workers, reduce wastages on site, reduce errors on site, and also, of course, reduce time. So that's money. And in every project, we have to look at the total construction cost. A good example would be private developers that are embarking on IBS, because to them, every cent counts, right? So we have seen a lot of developers that are venturing, actually investing in their own IBS solution, because they know that with IBS they can build faster, cheaper, and with more quality. And research has been done actually to compare the cost. Actually, we have actually done the research ourselves together with CREAM on a so-called neutral party involvement. We noticed that the most among the important items to be considered is how fast the IBS design comes in the progress. If it is based just on conversion, definitely will be higher. So IBS design must come earlier. The other thing is you need to use the correct layout. You need to optimize the mold. You need to look at the transportation cost, the lifting cost, and all. This has to be planned correctly. Remember the slide by Engineer Ng, plan. So it is very crucial in IBS, because IBS is no more agak-agak or no more last minute, because you have to pre-plan first, and then you manufacture and you assemble. Any disruption during that period, or if we have any party that is not willing to provide early information, then there will be some risk on the delivery. The other thing is that if you look at the cost itself, IBS, if you're talking about IBS core, it is mainly the building structure part and wall, ground and above. So, for example, if you're looking at structure cost itself, structure cost is just only maximum 25% of the total development cost. So any increase of the cost of structure due to IBS material, for example 20%, it will reflect 20% of the total project cost. If it reflects 20%, there's something is wrong in the calculation, definitely. Because again, structure cost is only about 25 or max maybe 30% of the total construction cost. And bear in mind that if you're talking about IBS projects, the precast component doesn't cover the whole structure part, because it will only cover the building part for the IBS core, for the superstructure part. And also, if you're talking about precast, there's no 100% precast solution. There's always hybrid. You need topping and you need joint. So if you're talking about the volume of precast component itself in IBS project, in the structure part of your project, sometimes it can be as low as 30 or 40% only, and you have 60% in situ. So so in essence, my point is, if you're looking at the cost, you need to look at the design, at the planning, at the correct layout, at the mold utilization. Then you will get a good price, similar to what the developers that are investing in IBS are doing. So that's my comment. Okay. Thank you again for the question. Very interesting question. Very valid questions. Very interesting question that can be shared to all the viewers. Thank you again for your involvement in this session. But before we wrap up our session, I would like to again offer perhaps 1 minute each for okay, let's start with TS Sharul first. Okay, to wrap up in 1 minute, your final comment.
Okay, thank you. Just want to thanks for all of the participants just coming to our webinar. So I would like to all of you who are willing to join our training program with Innovasia, especially in the deep learning and artificial network, because we would like to perform training on automate certain management process in construction, let's say the scheduling and so on. Okay. And my last word is to plan your work and also use the technology. Thank you.
Thank you. Engineer Eng?
Thank you. My last words. We live in a very special, extraordinary time now. Actually, the pandemic COVID-19 has caused a lot of disruption to us, to our life, as well as to the construction industry. I think as construction industry as a whole, we need to sort of quickly change and embrace new technology, move towards more digitalization and more virtual kind of things, and at the same time transfer some of the work to factory environment. At least we spread out the number of workers and minimize the number of workers to minimize the risk of infection. So I think we have to be positive, and we take this pandemic as a catalyst for us to change, to embrace something better. And as we emerge from the pandemic later on, I think the industry may look different from a time when we were before the pandemic. So I hope that we can just work together to effect this change. That's all I have to say. Thank you.
Thank you. So that's the end of our first series of our CR 4.0 webinar. Again, I would like to thank Engineer Eng and TS Sharul Fitri for your presence today. And also, thanks again for the Tvet students and Tvet lecturers that are joining us for today's session, sharing thoughts and questions that we most welcome in terms of your involvement. And again, we'll try to answer the remaining questions or the thoughts or suggestions, in fact, at the platform. So again, on behalf of Innovasia, thank you again. Please stay tuned for our next month's event in terms of the CR 4.0. We'll be looking for a new topic then. Okay, thank you so much. Okay, take care. Bye-bye.
Okay,
Thank you. Bye-bye.